Hello and welcome to the Edupedia World. Well, in this tutorial, I'm going to continue with the topic memory management in Java. This tutorial is specifically about learning how data objects are stored into Java Heap and to differentiate between the objects which are stored in Heap and which will be stored in stack. Okay guys, so let's begin. Well, it's a small tutorial, but this will be very beneficial if you want to learn complete memory management. So the first topic is stack and heap memory allocation. So we'll see how the memory is allocated into stack and heap in Java. Okay. For most the part, the various pieces, method, variable, objects of Java program live in one of the two places in memory, that is the stack or heap. Okay, for now, as in this tutorial, we are going to worry about only three types of things. One is instance variable, other is a local variable, and third one is a object. Okay, and you see how they are stored. Well, instance variable and object live on heap, and local variable live on stack. So let's see the same thing with the help of example. So here is the example. You see it is saying, let's take a look at a Java program and how its various pieces are created and mapped into stack and the heap. Fine. So now let's see that we are having a class caller and this is a simple class. It is not containing anything. Then we are having a class dog. It is having two objects. One is caller C and other is string name. Fine. Both of these are actually an instance variable, although caller C is a reference, but within a class dog, it is an instance variable for class dog, and same goes for string name. Okay. After that, within the same class, we are also having a main method, which is public static void main. Fine. And then inside our main method, what we are doing is we are actually creating a local instance of class dog. So for this main method, the local D that we have created as a reference of class dog is actually a local variable for the main method. Okay, although it's a kind of a reference, but it is still a local variable for main method. After that, in line number 10, we are actually assigning D is equal to new dog. So over here you see we are actually creating the object of dog in line number 10. Fine. After creation of object in line number 11, we are actually calling the go method of dog and passing the dog object that we have created. Okay. After that, let's go to the go method, which is line number 13. Okay. Inside the go method, which is taking parameter as dog. So it's void go dog and it's taking dog as a parameter. So over here, the dog will be a local variable of the method go. Fine. After that, what we are doing is we are doing C is equal to new caller. So over here, we are creating the object of caller, the reference that was present in the dog class. So in this method, we are actually creating the object over here. C is equal to new caller. So note that C is not a local variable. Why so? Because it's an instance variable that is created in a class dog. Then we are doing dog.setName ICO. Okay, then we are setting the name of dog over here. Fine. Then let's reach to the setName method. On the line 15, we are doing dog.setName. So the control flow goes to line number 17 to the setName method. So this method is void setName and it is taking string dog name as a parameter. So again, see this dog name string is a local variable to the method setName. So the scope of this variable will only be in the setName method. Fine. After that, we are having name equals to dog name. So what we are doing over here is we are actually assigning name variable to the dog name. Fine. And what is dog name? It is given to us in a parameter and we are assigning name with that. So this is our program and let's see how the memory is allocated to different instance variable and local variable and the objects. Okay, so this is a diagrammatical representation how memory is actually given. So you see on the right hand side, this portion we are having the heap and this box we are having the stack memory. So let's go and see. Okay. So you see over here the method, that is set name, go, main are stored in stack. Similarly, all the local variables, that is dog name, dog, d, are also stored in stack. And rest of the things, that is ICO, that is the string literal object we have created, will be stored in a heap. Similarly, the caller object that we have created will be stored in a heap. Then the dog object, which will contain two instances, that is name and c, will also be stored in a heap. Okay, now let's see how the memory is actually allocated to each one of this. So this is a line-to-line description which is telling us how it is done, stored in a stack. After that, line 9. The reference variable d is created on a stack, but there is no dog object yet. So if we check the line number 9, so you can see that only the reference is created, which is dog d. Although d is a local variable to the main method, so d will actually be stored in the stack since no object is yet created. Okay. Then in line number 10, a new dog object is created and assigned to the d reference variable. So when this new object is created, dog equals to new dog. So the reference variable is assigned to an object and the new object is actually kept in a heap. So this is what we have done. The dog is kept, the local reference is kept on a local variable stack. The dog object is kept in the heap. Fine. After that, we have line 11, which is a copy of reference variable d is passed to the go method. So when the copy of a reference variable d is passed to the go method, as we are seeing over here in line number 11, it reaches to the line number 13 where we are having a local variable dog to the go. So in the go method, the local variable dog is actually again stored in a local variable stack. So it is stored over here. Fine. So up till line number 11 only the passing is done. Then in line number 13 the go method is placed on the stack with the dog parameter as local variable. So not just the dog variable is placed but go method is also placed in the method stack. Okay. So you see when we talk about a stack memory, so each and every method is having a different stack memory. Each and every local variable will take a different stack memory. Okay. So there could be multiple stacks in Java memory. After that, in line number 14, a new caller object is created on heap and assigned to dog instance variable. So if I go to line number 14, what it is doing is it's actually creating a new caller object. So the reference C will be stored in a local variable stack and the object caller will be stored in a heap. Fine. So this is what we have done over here. Okay. So you see over here we have actually stored C although over here. Why so? Because C is actually not a local variable, rather it's an instance variable. Okay. So over here C is an instance variable. That's why we are storing it in a heap with the object caller. Okay. So this is a caller object that is created and C is referencing to the caller object. Fine. And then what we are doing is, it is also saying that it is assigned to the dog instance variable. So how we are doing that? When we do C is equal to new caller, since C is attached with the dog object and it's an instance variable, so it will be automatically assigned to dog. Okay. Then coming to line number 18, the name instance variable now also refers to the string object. If I check line number 18, the name reference variable is actually assigned to the dog name. So the dog name that was passed in set name on line number 15, which is a local variable. That's why, a set name and dog name is also stored in a local variable stack and method stack. Okay. Then dog name is assigned to name. Since name is an instance variable, so a dog name will be created. Okay, so name is there, it is assigning to a string object which is ICO because dog name is having ICO and dog name is also pointing to ICO. Fine. So this is how the memory allocation is done. Notice that the two different local variables refer to the same dog object, which is right. So this is like the dog object. And how two local variables? One is D. This is also, referring to the dog object, and there is another dog which is also referring to the same dog object. How this is done? Because when we are passing it, we pass D over here and dog which is taking over here. So both D and dog are actually referring to the same object. So that's why if you make any change in the dog, the changes will also be reflected in D as well. Okay, notice that one local variable, one instance variable Both refer to the same ICO. Similarly, name over here is also referring to ICO and dog name over here is also referring to ICO, which is a string object. Okay. After line 19 completes, the set name completes and is removed from the stack. At this point, the local variable dog name disappears too, although the string object it referred to is still on the heap. So, once you reach the 19 and you complete, you just come out after 20th line, you just come out of this block. So, as soon as you come out, the set name get disappeared from stack and dog name will also get disappeared from stack. But ICO will still remain because it is in the heap and there is a variable pointing to it. So although this reference is gone, but there is still a reference, so this object will still be there and it will not be, ready for garbage collection because there is still some reference to it. Okay guys, so this was a small example to explain you exactly how the memory is stored in heap and stack. So I hope this gave you a line-to-line idea, and now whenever you are creating your own program, you know like which line is actually storing something in heap and which line is actually storing something in stack. Okay guys, thank you. I hope this tutorial was beneficial. Let's meet in the next tutorial.